Hello astronomy enthusiasts from all over the world, I am Luis Miguel Azorin, and I welcome you to a new video of Astro Academy, your YouTube channel, your podcast, and your online school, about what we are passionate about, astronomy, astrophotography, and everything related to the universe and space. Are you tired of transporting your equipment to the field, and have you ever wondered what it would be like to have your own astronomical observatory? Well, today this is easier than ever, with the proliferation of telescope hostings like Cosmoscape remote telescopes. You take your equipment to this place, set it up, and we take care of everything related to remote connection and the security of your equipment so you can control it from the comfort of your home. Would you like to see how a remote astrophotography session unfolds from a telescope hosting? Well, tonight the forecast is quite good. And tonight we are going to conduct an astrophotography session from the Astrogrados Observatory, the innovation hub of the Cosmoscape Remote Telescopes project, the observatory where all the technology being implemented in Cosmoscape is being tested. So are you ready to enjoy a remote astrophotography session? I'm going to show you how it's done. Well, the first thing we're going to do is connect to the computer to which I have my astrophotography equipment connected at the Astrogrados Observatory, which I have right here. This is the computer to which my telescope is connected, and in fact, we can already see it here. My telescope is this one we have here, and over here we have some telescopes from other colleagues. At the moment, the observatory's roof is closed. We're going to open it in a moment, but before opening it, we need to check the weather situation there. Because I am more than 500 kilometers away from this observatory, and what better way to do it than by checking the security cameras? We have some clouds dissipating to the south, but generally clear skies. So we are now ready to start the equipment and open the observatory's roof. Let's do it. We come over here to the suite, Cosmoscape Assistant, which allows us to control the entire observatory completely. And in fact, over here I have access to my equipment. As you can see, I already have the computer turned on. Obviously, I am connected to the computer, and what I am going to do is turn on the telescope column with all the connections it has. If we now go to the security camera, we can see how the equipment is starting up, and we are going to open the roof. We come back to the Cosmos Instant, and from here, we have control of the roof opening, which is currently in a closed state. Everything you are seeing here will be enjoyed in exactly the same way by all those users of our telescope hosting. We are going to open the roof from here. I press here, and if we go to the camera, you can see how the roof of the Astrogrados Observatory is opening at this moment. Well, we already have the roof of the observatory open, and as we have verified, we have an absolutely clear sky. We are going to start setting up the astrophotography session. Here, in Cosmos Assistant, we have already checked that the telescope is connected, the computer is connected, and everything is correct. So let's minimize all this and open the astrophotography suite. The most recommended way to control equipment remotely is through the Nina Astrophotography suite. In this case, I have all the devices connected through a Pegasus box, so I am going to open the Pegasus application. And it is interesting to have this application open because it will give us a lot of information about the status of the connected devices and about the weather conditions at the observatory, since this device has sensors for that. And with the Pegasus Unity platform open, we are ready to open Nina. And with Nina open, I am going to connect all the devices: camera, filter wheel, focuser, rotator, the mount, auto guiding system, in short, everything. By pressing this button here, I connect all the devices. Alright, everything is connected and working. Since I will start the astrophotography session in a little while, what I am going to do first is set the camera to cool down to Sete, so that later, when I am about to start the astrophotography session, I can lower it to -10 degrees C, which is the temperature I usually work at. This way, When starting the astrophotography session, the camera will take less time to reach the target temperature and we can start earlier. And with everything connected, we would be ready to plan our astrophotography session. How do we plan a remote astrophotography session? Well, we are inside the environment. Little girl. Actually, we could do it exactly the same way as we would set up an astrophotography session with the telescope right next to us. For this, we go to the Sky Atlas and simply have to search for the object we want to photograph. Let's try with M42. I press search. And here we have the object. We send it to the framing assistant. And here we have the simulation of the object exactly for the equipment I have installed in the Astrophotography observatory with the camera sensor and the focal length at which I work. So it's as simple as finding the framing we want to photograph, applying exactly the rotation angle at which we want to work, in case we have a rotator installed. In my case, I have the ZWCAA rotator installed, which, by the way, is already updated within the ZWACR course of astrophotography. And basically, having found the framing and applied the rotation angle at which we want to capture this object, the only thing we would need to do is send the telescope towards the object if it's already night, or save the object to add it within a line astrophotography sequence. However, the most common practice when doing remote astrophotography is to capture the same frame over successive nights. This is to accumulate the largest amount of data possible of the photographed object in order to obtain images with a great amount of detail and depth. That's why in this session I am not going to photograph this object, but instead I am going to load an advanced sequence to continue photographing some objects from which I have already been obtaining data on previous nights. So I come over here to the sequencer, advanced, and what I am going to do is load a sequence for mosaics. Actually, I am not going to create a mosaic, but it is a sequence that allows me to conduct multi-object sessions, as we are likely to have clear skies throughout the night. I am going to take the opportunity to capture several objects. By the way, I am not going to stop to explain exactly how Nina's advanced sequencer works, because on this channel, you already have a podcast episode on astrophotography specifically dedicated to Nina's advanced sequencer, where we teach you how to set all this up. And, in addition, we provide you with a link so you can download these sequences and use them yourself. Well, in this sequence, I have the option to photograph 2 objects, although I could keep duplicating and photographing more objects, but 2 objects, that is my goal for tonight. First, in panel 1 that I'm going to photograph, I will continue capturing a complex of nebulae located near the Cone Nebula. So I am going to drag this simulation over here. Here it gives me a graph of the object's status and what time we will have complete darkness. Starting from approximately 8 p.m., 8:15 p.m., we will be able to start capturing astrophotographs. Not with total darkness, but with enough darkness to start practicing astrophotography. Basically, what is known as nautical twilight or astronomical twilight. So, since later the camera will need to finish cooling down, I will tell it to start. All these processes I have here at 20C. It will connect us. The equipment will cool the camera to -10 degrees, this time for sure. And since we already have it pre-cooled to 0 degrees, I will tell it to take only 5 minutes to do so. It will open the flat panel, it will start the camera's anti-dew heater. We will tell it to shoot without a filter, because we are going to photograph an object with a lot of reflection nebulae, and it is preferable to do it without a filter. Additionally, we will take advantage of the quality of the sky there, where the Astrophotography Observatory is located and where it will be found. Also located is Cosmo Remote telescopes. It will move the focus to position 9500, perform a focusing routine, and unparking us. The equipment will move, center the frame, and rotate the frame with the rotator. And if all these steps have gone correctly, it will start the auto-guiding and we can begin the astrophotography session. All of this that I am showing you here will be done by the equipment in a fully automated manner. I can be in front to check that everything is going well, but all of this will be done completely unattended. Let's continue downwards. Here we have the triggers for meridian flip, filter change, and autofocus. All of this, as I said, is explained in detail in the podcast episode about Nina's advanced sequencer. And here we have the capture of the first photographs of this nebula complex. Until what time do I want it to be capturing this object? Well, I'm going to tell it to capture until 2 in the morning. Because, as we see here, at 2 in the morning, the object is already quite low on the horizon and it's not worth continuing to capture it. Moreover, it will be hidden behind the observatory wall. So this first object will be captured until 2 in the morning. We are going to tell it to capture 600-second exposures of the light type with no filter, as we said, applying dithering every 3 photographs. Here we have the automation of the flats capture for this object. Initially, I captured the flats and the dark flats. The next day, replicating the rotation angle applied by the rotator for the object in question. So I'm going to remove this entire module, and here we already have the second panel, the second object we are going to photograph. The object I am going to configure in this case will be a continuation of a sequence of photographs I already captured of the Leo triplet, which I started a couple of weeks ago. And as we can see, around 2 in the morning we have it quite high. We continue configuring. In this case, we are going to tell it to stay without a filter, it will apply an autofocus routine, and we will instruct it to photograph this object. Until 10 minutes to 7 in the morning. As we can see here, at that time we are within nautical twilight, which allows us to practice astrophotography. We finish configuring the photo capture for the second object. Exposures also of 600 seconds. Without a filter. And likewise, I am going to remove the capture of flat. Because I will do it tomorrow. And here we would have the completion sequence. It will stop, the auto-guiding will park. The telescope will close the flats panel so that the telescope is covered. It will move the rotator to the mechanical position 0, that is, the parked position. It will also move the focuser to position 0 and will warm up the camera for 5 minutes. Finally, when it has completed this entire process within this advanced sequence of Nina, it will disconnect all the equipment and be ready for me to connect to the computer tomorrow and check that everything has gone correctly. I have set the end of the session, the end of image capture at 6:50 in the morning. Therefore, we need to configure the closing of the observatory roof so that it closes at this time or shortly after. So we come back again to Cosmo Assistant. And here, in the closing time programming, we are going to set it to 7 in the morning. Obviously, even though I have set this closing time here, all the sensors of the Astrogrados Observatory will be active so that if something fails, if it rains, if the wind picks up too much, the roof will automatically close. And in the worst case, I would have a complete astrophotography session of black photographs, but the equipment would be completely safe. As we can see from the camera, we already have some stars appearing in the frame, so the session is going to start very soon. In fact, we have set it for 8 in the evening, and it's 10 minutes to 8. So the only thing left for us to do is click here on play. And all of this is now set in motion, waiting until 20 likes to start everything. As I tell you, it becomes incredibly addictive to be in front of the screen, watching how our remote equipment works. But all of this is designed for the equipment to work completely unattended. We can go home peacefully. We can go to sleep knowing that our remote equipment will be working for us throughout the night, and tomorrow we will have all these sequences of photographs that we have set up on our hard drive. Without a doubt, remote observatories are representing an exponential leap in the quality of astrophotography for enthusiasts. I remind you that you too can enjoy all of this. In the first comment and in the description of this video, you have a link to the Cosmoscape website, remote telescopes, where you can see all the information about our telescope hosting,